When we last left Timmy, he was playing in his backyard, pretending to be his favorite animal, a chameleon. Oh yeah, and he also ate a butterfly. We followed the path that the ingested butterfly took down Timmy's upper gastrointestinal tract, from his mouth to his pharynx, down his esophagus, and through his stomach. Now let's continue on our journey through Timmy's digestive system as we follow the path that the food takes through the lower gastrointestinal tract. We know that liquefied food and gastric juice is released by the pyloric sphincter a little at a time from the stomach into the duodenum, which is the first section of small intestine where digesting food enters from the stomach. A lot of people think that this food is now digested into products that can be absorbed into the bloodstream, but that's not the case at all, because full digestion of the food still requires a lot more work. As soon as the liquefied food and gastric juice enters the duodenum, the acid and partially digested food stimulates the pancreas to secrete bicarbonate, water, and many different digestive enzymes, which flow into the duodenum to mix with the gastric juice. You may remember that bicarbonate is a base, and that bases neutralize acids. So when the bicarbonate secreted by the pancreas mixes with the gastric juice, it neutralizes the acid. Meanwhile, digestive enzymes are secreted from the pancreas as zymogens, which you may remember are inactive precursors of enzymes which require a change to be activated. These zymogens are activated by other enzymes in the duodenum and then start breaking carbohydrates into smaller sugars and proteins into peptides and amino acids. Once the carbohydrate chains have been broken down into monosaccharides, they can be transported across the luminal membrane and into the epithelial cells of the small intestine. Likewise, proteins and peptides can't be absorbed by the small intestine, but once they are broken down into their component amino acids, these are easily transported into the epithelial cells. However, fats are a little more complicated. You see, fats, which are also called lipids, are hydrophobic. They repel water and clump together with other lipids because when they clump together, they have less interaction with the water. But this means that they are insoluble. They won't go into solution, and they aren't available for soluble digestive enzymes to break them down. Fortunately, our liver produces bile salts, which coat the lipids and keep them separated into tiny droplets that don't clump together. These tiny coated droplets give the digestive enzymes enough surface area to gain access to the lipids and break them down. One such digestive enzyme is lipase, which is an enzyme that breaks lipids down into monoglycerides and fatty acids. These monoglycerides and fatty acids can then be absorbed by the small intestine. Although the liver produces bile, it is stored in the gallbladder, which then releases it into the duodenum when digestion is taking place. The small